Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter atoms. Okay, let's go through it. The question is, an electron in the hydrogen atom initially in the fourth excited state makes a transition to nth energy state by emitting a photon of energy 2.86 electron volt. The integer value of n will be how much here? So here the keyword is what here? Emitting a photon. Emitting a photon. That means this is the part of emission spectrum. Okay. So normally what happens that here, let's take for example, here I have taken here the initial level n1. Now, so what happens that one electron receives the photon, or we can tell receives the energy in the form of photon. It goes to the higher energy level, that means n2. Here it stays for how much time here? It stays for here how much time? 10 to the power minus 8 seconds, and after that it comes back here. Okay, so in this situation what happens that here, this is the part of absorption spectrum and this is the part of emission spectrum, we can tell here, emission spectrum. Okay, so absorption spectrum means low energy state to the high energy state, and emission spectrum means high energy state to the low energy state. Here I have drawn only single line for the emission spectrum, but emission spectrum are so many. Absorption spectrum only one, but emission spectrum how many? So many. Okay, so here we are talking about the emission spectrum. So in the question we can see very well, initially in the which state? Fourth excited state. That means fourth excited state means value of n2 will be how much here? 4 or 5 here? 5, because fourth excited state. Ground state n equal to 1, first excited state n equal to 2, second excited state n equal to 3, third excited state n equal to 4, fourth excited state n equal to 5, is it? And after that it is coming to the nth state here. Okay, so n1 is n, it is coming back, this one I am talking about here. Okay, so in this situation we are going to use the Bohr's which postulate? Third postulate. There is the 3 postulates, but we will use here the third postulate. So according to that, what will happen that here? En2 minus En1. High energy state minus lower energy state is always equal to energy of the photon, h nu. Okay. And what is the value of the En2? Remember that here, minus 13.6 Z square by n square. Hydrogen means Z equal to 1. So minus 13.6 by n2 square. Okay, minus En1 means minus 13.6 by n1 square is equal to how much photon it is releasing? 2.86 electron volt. This is also in electron volt, so this is also in electron volt. Electron volt, both the sides will cancel out. Okay, so this will come here 13.6. If I take here the common, it will become a C minus minus plus. So I can write here C 1 by n1 square minus 1 by n2 square is how much here? 2.86. Okay, after that what this will happen that here? Can you see? We can write here 1 by, not 13.6, I will take this side. So 1 by n1 square. What is n1? We can tell here n. So 1 by n square minus n2 square. That means how much here? 5 square. That means it will become here the 25 is equal to, we can tell here 2.86, and 13.6 will come this side here. This is electron volt, this is electron volt, both will cancel out. Okay. So now I can write here, see, this is the 1 by n square is equal to, I can write here 1 by 25 plus this decimal, after decimal 2 digits. Here also I will make here the one more 0, and this decimal will over. So 286 by 1360. Okay. So now I can write here, see, 1 by n square is equal to 1 by 25 means 0.04, and 286 by 1360 approximately, when you will simplify this, it will come here 0.21. Okay, so from here I can write here 1 by n square is equal to, this will become here the 0.25. Okay, so if I write here the what is the value of the n square, that means 1 by 0.25. 1 by 0.25 how much here? 100 by 25. That means we can write here the 4. Okay, so what is the value of the n? The value of the n is coming here the 2. N equal to 2, or what we can tell, if they ask in a another way, we can tell n equal to 2 means first excited state. It is coming from fourth excited state to the first excited state, then only it will release a photon of 2.86 electron volt, and here the value of n is 2. Okay, So students, I hope so. This video based upon the concept of excited state and Bohr's third postulate is very clear to you. Keep studying, keep growing.